All right, and next up on our agenda today, we have a keynote address from Dr. Janet Vertesi. Dubbed Margaret Mead among the Starfleet in the Times Literary Supplement, Janet Vertesi is an associate professor of sociology at Princeton University, where she specializes in the sociology of science, technology, and organizations. For the past 15 years, she has studied how distributed robotic spacecraft teams work together effectively to produce scientific and technical results, including the Mars Exploration Rovers, Cassini, the Europa Clipper mission, New Horizons, and the Interstellar Probe. She is the author of many peer-reviewed journal publications in the field of human-computer interaction and computer-supported cooperative work, alongside her publications in the social studies of science and technology. A faculty member at Princeton's Center for Information Technology Policy and an advisory member at the Data and Society Institute, she has written 2 scholarly books, Seeing Like a Rover, How Robots, Teams, and Images Craft Knowledge of Mars, and Shaping Science, Organizations, Decisions, and Culture on NASA's Teams. Vertesi is presently writing a book about the ups and downs of funding cycles at NASA, and a book about her series of unusual evasive experiments in personal data privacy. You can read more about Professor Vertesi and access her publications at janet.vertesi.com. Janet, thank you so much for being here this morning and sharing your time and expertise with us, and the floor is yours.
I'm absolutely delighted to be here. Let me get my presentation loaded and get started. All right, can you see the slides? Oh, good. It's a pleasure to be here. I'm really delighted to be speaking to you today about some of my research with NASA's robotic spacecraft teams. I'm going to be talking about a project that took place a long time ago, but I think still has some really important lessons for us today. But I'm going to let the PI of this project have the first word, even though he's not going to get the last word.
I mean, part of the reason that I view them as having personalities is, you know, if you were there when they were born, you know, they went from being inanimate hunks of metal to things that actually did something and moved and behaved and took on personalities. And I was never able to let go of that, because it was, as you watched them first come to life for the first time, that to me was when I first developed that feeling. And nothing that happened since then has changed that.
So the story I'm going to tell today is a story of what we would now call mixed autonomy. And I want to tell this story because I think it's very important in an era of increasing automation of human robot tasks and increasing interest in individuation. And what I mean by that is that mixed autonomy offers a paradigm for how we could think about humans and robots working collaboratively together without putting so much of the task onus on the robot away from the human, and also to move away from thinking about humans as individual actors who interact with robots, and more to thinking about groups and teams. And that a challenge for us in designing appropriate flight software and hardware that work is that they work with a team of people on the ground, and that they are careful to integrate what the robots do well with what humans do well, considering the whole group of humans on the ground. That's a bit of a mouthful, but I promise you we'll get there. So, you know, Spirit and Opportunity, the rovers are not the first robots to explore new planets. You might be familiar with these 2 robots. They did a fairly good job, well, maybe not a particularly good job, because what was the first thing that happened when they landed on this new planet? They had an argument, right? They fought. And what did they fight about? Which way to go. They couldn't make a decision about which way they should go. One of them wanted to go this way, the other one wanted to go that way. They ended up having a fight. 3PO kicked R2, they walked off in different directions. One of them got captured by Jawas, and the whole story, you know how the story goes, right? But the key thing here is that when we're working with robots on other planets, one of the biggest challenges is operationally is making a decision about where the robot should go and what the robot should do. And with our human robot teams, those decisions tend to be made in groups. Now, it's very appealing to take an engineering view of this as a problem and say, well, first of all, we don't want this conflict. We don't want them to hate each other. And also it's a pretty straightforward task. Are there settlements that way or that way? We can automate this away. This is the kind of thing that we could create some ease in the system by making sure the robots make really good decisions. And another way to put what I want to say in this talk is that I think when we give that task over to software, when we conceptualize it as just a task, we miss a really important opportunity for mission success, ironically. So to make this point today, I'm going to draw on my field of sociology, particularly sociology of science, engineering, and technology. You may have heard of sociology. It's the field over here on the left. And I'm actually not entirely sure where engineers would put themselves, or software engineers would put themselves on this list, possibly observing with some degree of bemusement at the interactions among these different scientists. But what I want to argue, though, is that sociology has some very powerful insights to offer, specifically around interactions among humans in groups and teams, and in teams with robots. And so it's actually been put to really surprising and powerful use by looking at how people interact with machinery of all kinds, whether it's robotic or algorithmic or whatever. And I know that often I hear when I speak to scientists and engineers that they're somewhat baffled by the irregularities of human interaction and behavior. One of the things that's so great about sociology is it gives us some tools, it gives us some rules and premises by means of which we might understand regularities and explanations for human behavior. And I don't mean individual human behavior, that's more the domain of the psychologist, but really thinking about humans in groups. Teams, organizations, societies, cultures, those are the kinds of things that sociologists really excel at. And that's very important when we work with human robot teams. And the team I'm going to talk about today is a team that commanded 2 rovers on the surface of Mars back at the beginning of the 21st century. And so these are old robots. I'm talking about Spirit and Opportunity that were launched in 2003, arrived in Mars 2004 for their 90-day mission, which they outlasted by several degrees. You can do the math, but at least like multiple years. One of them lasted 7 years. Another one I think it was about 12 or so before they their missions finally ended. And we've flown way more capable rovers since then. We've now even flown things that fly on other planets. We're developing more things that fly on other planets. And we've also made huge advances in artificial intelligence, autonomy, and flight software since then. So why would we go back? Why would we go back to Spirit and Opportunity? What lesson is there for us with these very antiquated pieces of hardware and software? Why would we think about that? And again, I'm going to try to open up that space between human and robot capabilities, because that mixed autonomy space is where human robot teams can and do achieve extraordinary successes. So in going back to this era where the robots were less capable, we can see what happened among the humans and the team that enabled the robots to be so extraordinarily successful. And the tools I'm going to use, my own methods, are ethnography. Ethnography is a practice technique among sociologists by means of which we sort of embed ourselves with different cultures and come to understand how they work. This was advanced initially by anthropologists who would go to some island out there and be like, what are the natives doing here, and write about it. And I do that, but I do that with scientists and engineers. And I've been doing that now for about 15 years or so, working with NASA's robotic spacecraft teams, beginning with the Rover team, but also expanding to Cassini, to Europa Clipper, and a variety of other projects across NASA's portfolio. But the point with ethnography is to do this kind of a deep hanging out, this ability to really integrate yourself with the culture and to systematically record and analyze and understand why it is the people in that group are behaving the way they are, why they make the decisions they do, why the things that seem natural or rational to them seem natural or rational, what kinds of processes and cultures are at play in these different groups. And one of the things I can tell you from working with many different robot teams, human robot teams, is that they're all quite different. They all have their own unique local culture. You've probably also encountered this as you move from team to team, or even as you try to coordinate between APL and JPL, that you're constantly working across these different cultural environments. That's the kind of thing that I like to elucidate. So that's so much for the people. Let's just remind ourselves a little bit about the robots we're talking about that are part of these teams. These are the 2 Mars exploration rovers. They were again constructed in the early 21st century, and there are certain things that they can do. So they have, I think it was 9 different cameras, 2 color ones that were used for science and scientific capabilities, 2 black and white ones, again mounted on the top of that mast for navigation purposes, and several of them mounted underneath the solar panels that were used in order to detect hazards in the terrain. And this fed right into the onboard computer to figure out if the robot was coming up against some kind of hazard and needed to drive around it. And there was also a microscopic imager, a single camera with a high intensity lens at the end of the arm. And the robots were equipped with the tools of a robotic geologist. That was part of the payload associated with this mission. They were part of that initial group of missions that were there to follow the water and look for signs of past water on Mars as an opportunity to look for life on Mars. But from the software perspective, there were a lot of things these robots can't do, which I think is just as interesting. So they had onboard artificial intelligence, but it was pretty limited. They could tell if they were driving up against some kind of rock or hazard and that they should drive around it, but they didn't always get that right. And I remember when I was working with the team, there were a lot of upgrades to the software to try to get it so that if it went around an object, it wouldn't sort of stop midway and then drive off in a different direction. So that was always something you had to be careful of, was the robot might not know exactly how to continue on the same path. And the robots also knew that if you came up to a cliff, you shouldn't drive over it. Right, so they had some very limited onboard capabilities, but it was in the limitations actually that I noticed that the humans that worked with them developed some extraordinary capabilities that created exceptional synergies across the human robot team. So despite, in fact, because of the limitations of these robots, there were things that the humans and the teams could do that made for the extraordinary success of this team. I first started to notice that there was a particular way that this team worked with the robot very, very early on when I started my first part of my ethnography. And one of the team members said, well, you know, when you work with the team for a while, you sort of learn to see like a rover. And I was like, see like a rover? What is that? What could that even mean? So for the next major part of my talk, I'm going to outline for you what it means to see like a rover, and particularly to see like these rovers. And I'm going to argue that this brings together techniques of visualization, but also enrolls the body, embodiment, and understanding. And that those two things taken together are also together enrolled in the teamwork and the social solidarity of the team. And it was this combination of things that occurred, again, at that gap between what the robots were capable of and what the human team was bringing to the table that allowed the teamwork to really flourish and operate these robots on Mars. So let's look first at the visualization. The first thing I noticed with the visualization was that people were very proud of how they altered their visual perceptual apparatus to fit the robots, not the other way around. This was very obvious with respect to these images taken by the hazard avoidance cameras. Hazard avoidance cameras have a 180-degree view. There are fisheye lens, so you can see more. And this is, again, enrolled right into the onboard AI capability, so the robot knows whether or not it's going to drive into a problem, right? So, and there was a sort of apocryphal story told about these pictures that when they first came down from Mars, that some unwitting reporter said, oh my gosh, Mars is so different, it's really curvy, right? And of course, Mars isn't really curvy. It's just, this is the way that the lens is distorted. Now, it would take 2 seconds to throw this into some processing software and correct it to a human view. It would probably take 4 seconds to throw it now into something that would correct it into maybe more than 4 seconds, but into some kind of augmented or virtual reality view. Nobody did that. Nobody did it. Instead, what they did is they had stories and pictures around them that spoke of their expertise with looking at pictures like this in their native form. One of them used this picture on the right that was taken from when it was at the lab to say, I use this picture on the right to make the correction. Just in my head, I now know what it's like to see this way. Another one, the scientist would put up a picture, he would say, well, don't forget, objects in the mirror are closer than they appear, right? And the whole point was to remind everyone of the visual transformation that was necessary because there was some kind of visual distortion when you looked through the rover's eyes. Now, that doesn't mean that they didn't, manipulate images in order to see them. Here is an early example of the kind of VR stuff that we see today, which is in the anaglyphs, the 3D anaglyphs that they would put together, taking a right eye image and a left eye image from the navigation cameras and putting it together and putting on those 3D glasses like you were going to go see Michael Jackson in the theater in 1984. I recognize that reference may be too old for many of you on the line. Regardless, so the scientists and engineers would put these glasses on in order to see the terrain around them. And what they would say is, I look at it like this because in 2D I could see there's kind of a ridge here, but in 3D it gives me a better size of the shape and the slope of that ridge so I can evaluate them as obstacles. Now I want to point something out here. The point here is not to understand the size and shape of the ridge just by themselves. It's to evaluate them as obstacles. It's to see them as the rover sees them. They're not correcting for a human frame. They're only doing the corrections so insofar as to correct for the stereo displacement of the eyes. So this is now something that humans can see with their eyes, right? Because the robot's cameras were 30 centimeters apart, not smaller. But that's the main correction here. Otherwise, they're interested in seeing where the rover can drive. They want to see the terrain like the rover. And that also produced visualizations like this. This is a lily pad map. The lily pads are areas on Mars where the engineers determined that it was safe for a rover to be for a while because it's free of obstacles, but also because it was a good place for it to soak up valuable solar power and energy for its solar panels. And so they would create these maps like this around the terrain, which are not maps of Mars geologically. They're not even maps of Mars for human exploration. They are maps of Mars for what the rover can and should do and where to say for the rover to go. And the scientists also produced images like this too. I witnessed the team put together very complex contour and slope maps for the entry of opportunity into Victoria Crater, because what they were interested in doing was not showing, the stratigraphic layers of the section, but to see the crater as the rover would need to drive safely in and out of it. And so again, these kinds of transpositions enabled them to see the terrain the way the rover needed to encounter it. And people would tell very rich stories about the rover's point of view as it was driving. As one person said, you have to think that the rover's view of the world when it's driving is like your view of the world. But imagine yourself trying to go through a dark, cluttered room with nothing but a flash bulb. So you kind of like walk a little and then you look and you pop the flash and then you walk a little more and then you pop the flash, right? That's how the rover sees the world when it's driving. So these kinds of visualization techniques, again, did not transpose the rover's perspective into the human. They allowed the human to step into the rover's shoes on Mars and try to get a sense of what it was the rover was seeing and experiencing. And so the transpositions, the visual apparatus they were using was one that sensitized them to the robot, not the other way around. And this also continued with a series of embodied techniques, physical bodily techniques, not processing on the screen, but in your body, that forged a physical connection between the robot's experiences on Mars and people's team experiences on Earth. So one way this happened was through stories people told about how they kind of got to understand the robot and how it felt. So one person said, I do a lot of marathon running. And so I know if I run a really long stretch one day, I know how I'm going to feel the next day. I'm going to feel kind of sore and stiff. Well, I also know if the rover took a long drive yesterday, I know what it's going to feel like and be like tomorrow. I know what kind of stiffness it's going to have tomorrow. The rover, someone else said, it feels its suspension. It knows its pitch and its roll, and they move their body as they said that. It knows when it's cold to turn on its heaters to keep warm. Now, this person was not narrating the onboard series of commands the rover used in order to, like, its detection mechanisms to say, oh, it's cold, turn the heaters on, but physically moving their body along with the robot to insinuate its pitch and its roll on Mars. Similarly, people talked about how the rock abrasion tool was a sense of touch. And when they saw the readouts that came back, when they saw the graphical readouts that came back from that tool, they felt the robot's like touching apparatus on the surface of Mars. Your eyes become the navigation camera. Your eyes become the panoramic camera. And these were the kinds of stories that people told about the kind of fusion of their sensory apparatus with that of the robot. And it got so extreme that sometimes people were like, look, when I'm working with this robot, like, I'm not me, I am a robot. I am the rover. Now, I want to point out a distinction here because there's a lot of anthropomorphism that went on with these robots. And, humans like to anthropomorphize things that they work with anyway, but things went a little bit extreme with these robots. So in particular, they had different personalities. And everyone, when I talked to on the team, could tell me that, Opportunity was the glamour girl. This was the white collar rover. She went to Mars. She fell into a hole. She opened her eyes and there's evidence of water. She was born with a silver spoon in her mouth. Didn't have to work a hard day. This was earlier on in the mission. Opportunity worked a lot of hard days later on. Spirit was the blue collar rover, more hardworking, a little more hard nosed. She went all this way to find water and there was no water, but she's not the kind of rover to go 300 million miles and give up, right? So these kinds of stories circulated on the team about the rover's experiences and animated them as having their own personalities. And if you remember at the beginning of the talk, I have that moment where the PI talks about how they move and behave and take on personalities. So yes, there is a large degree of anthropomorphism going on here. But what I also want to point to is there's a parallel thing happening at the same time, which is a kind of technomorphism, where instead of us projecting human experiences and characteristics onto the robot, we're also projecting robotic characteristics onto the human. Let me tell you a little more about what I mean. So people would use their wheelie chairs to go around in the room to sort of show how the robot was going to move. They would put post-it notes on their forehead to show how the pan-cam frames would turn out. In the software for determining where the panoramic camera would take pictures, it showed up as little yellow squares. And to get a physical sense of how that square would kind of operate from the robot into the environment, they would approximate that by literally putting a post-it note on their forehead in order to kind of project that out into the screen and make that connection. When we're training new rover drivers, you can tell they start to get it when they move. We're talking about the instrument device, the deployment device, the arm, and they start moving their own arm. So there's a way in which the people who work on the team learned to move their bodies and operate the way that the rover did. Now, there's one way to look at this and say, clearly this is communication, right? So if I'm trying to command something, it helps me to say to you, oh, move it like this. But it wasn't. I witnessed people doing this in the room, like by themselves, speaking into a teleconference call. So there was no video, right? They're just doing it to get that sense in their own bodies. And this became so intense that there was a set of characteristics I observed on the team that I soon came to call the rover dance. And this is a patterned way in which people moved their bodies and discussed their bodily motions as associated with the rover at every step of the way. I can't show you this video because of putting it on YouTube, but what I will do is play this clip and I will demonstrate to you what this person is doing as they're talking at the same time.
And then the other time I use it is when I'm looking in the atmosphere, because I want it. My body, by the way, is always the rover. So right here is the front of the rover. My magnets are right here. And my shoulders are the front of the solar panels, and that's the rest of it. And so I got all kinds of things sticking up over here. But when I'm taking a picture of something in the atmosphere, it helps me to sort of look up, being the rover, and this is the front of me, and put my hand, you know, point my hand to wherever, whichever vector to whatever I'm looking at.
So my body is the rover. Here's my magnets. Here's my solar panels. And here's all my stuff on my back. And it helps me to look up and be the rover, to move around and know where I'm taking the picture or what observation I'm achieving. This kind of physical connection, again, isn't the rover's arm is like my arm. It is instead a transposition of the rover's physical apparatus and sensing apparatus into the human body. And again, this was used extensively in operations, as I will describe, but it also forged a very sort of symbiotic or empathetic relationship between humans and the robots in space. So one team member said, when the rover isn't healthy, we feel it in our bodies. When there were dust storms on Mars, people hunched over, they could feel the tenseness, the tension in their bodies and hear it in their footfalls. They also had very elaborate stories for why certain things were happening on Mars and on Earth at the same time. There's one middle-aged scientist who said, you know, one day I was working in my garden and all of a sudden, I don't know what was going on with my right wrist. I couldn't move it out of nowhere. I got to the meeting and Spirit's right front wheel was stuck. Things like that, you know, I am totally connected to that robot. My arm stopped working because Spirit's right front wheel stopped working. Now, if this is not a one-off, this happened repeatedly throughout the team. Here's another younger male engineer. You know, I screwed up my shoulder and I needed surgery on it around the same time the Opportunity's shoulder joint started having problems. And I broke my toe right before Spirit's wheel broke. So I'm just saying, I don't know, like, maybe, I don't think there's any magic involved, but maybe it's some kind of subconscious thing. I don't know. Regardless, people started to narrate their experiences on Earth through this technomorphic lens of what was happening to the robots. So what is this all about? Like, what's going on here? Is it because the robots are human-like? Well, actually, the whole thing about seeing like a rover is that they're not human-like. So we're not anthropomorphizing them because they're like people. We're technomorphizing ourselves because they're not like us. So that isn't the reason why. Is it because they're cute? You know, these things are large hunks of metal. If you saw them in person, apparently they sound like someone put a whole bunch of empty cans in a bag and threw it around in a windy day. Like, I mean, they're not the most appealing objects when you first meet them. In fact, I would argue, and I will argue, that the cuteness comes later. It's not the reason why we behave the way we do, but because we behave this way, we then think they're cute. I'll elaborate more on that in a minute. Is it because they lasted for a long time? Not necessarily. People reported starting to build these kinds of relationships with them before they were launched and in the very early days of their operations. I can report that it took about 6 months to figure out how to see and feel like a rover. And at that point, I could feel spirit and opportunity in my body with the different kinds of stiffnesses associated with them, etc. Is it because humans just love anthropomorphizing things? Well, I mean, we don't anthropomorphize everything, and we also don't technomorphize ourselves with everything. So that can't be the only thing going on. Or finally, it could just be because they're rovers. And I heard this a lot when I worked on other teams where there were orbiters, and they were like, well, that's because they're rovers, and so everyone likes rovers. You know, interestingly, I have since worked with orbiters that are organized socially a little more like the rovers, and I see more of these same kinds of dynamics. So it's not necessarily predicated on the physical body of the robot or necessarily on its capabilities. Instead, I want to point to that space again between what the robots can do and what they can't do, and where the humans are filling in the gaps. And a huge part of filling in that gaps is making decisions and working together as a team to achieve consensus on a plan. Now, the main operational word here is consensus. The Mars Exploration Rover mission team operated as an emphatically flat hierarchy where they had to produce unilateral agreement to their plans. Now, there's advantages and disadvantages always to every social order. But what was interesting is despite the tremendous personality of the PI, certainly by the time I joined the mission, the PI was not calling the shots. The only shot he was calling was making sure that everyone was working together collaboratively to come up with unilateral agreement on the plan. And it's that kind of teamwork, that space between the human and robot capabilities allowed to flourish. That kind of social order where people could work together collaboratively on this plan and make those decisions was a huge part of why they felt the way they did about the rovers and why they succeeded the way that they did. So first, I'll just indicate that these techniques of seeing and feeling and being like a rover were actually deeply involved in the operational capabilities of the spacecraft, largely in those moments of decision making. So as one person said, you know, in order to be prepared for my job, I need to be that vehicle. That's why I use all that visualization software. It's all about intuitively being able to make decisions because you're getting questions on the fly. You're going to have to answer them on the fly. You're not you're the rover. I think of myself as a rover because I have to be able to call those shots. I need to know where I am as the rover. That's a huge, huge part of my job. Now note that the visualization stuff is not about giving you the information to make those decisions. It's about giving you the intuition to answer questions on the fly that may not have answers that are visible in the software, right? It is because you can inhabit the visual and bodily apparatus of that vehicle so effectively and with such practice that you can get questions and answer those questions on the fly and think creatively also about the capabilities of the robot given its circumstances. And that's what these sort of seeing and feeling like a rover techniques give you in the moment, is that ability to do your job effectively. Now, when are you getting those questions on the fly and answering them on the fly? You're getting them in meetings like this. Well, they began like this, but they were only like this for a very short time, and then they've transitioned online. But largely, these were, a group of scientists and engineers coming together, looking at the data that had come down the day before, and trying to decide, like R2-D2 and C-3PO, which way they were going to go based on that data. Now, the important thing was that it wasn't just a question of what they decided. It was a question of how they decided. The key element for this team, always, that the PI continued to reinforce, was that they had to decide together, that whatever the team decided together was the right thing for the robot, because then they would have considered as much as possible all the available information and be able to decide collaboratively with consensus about what the robot should do. What this meant is that these meetings, ultimately, when I observed them, took under an hour for each robot. For those of you that have worked on these kinds of meetings, they were SOWG, Science Operation Working Group meetings. They brought together the scientists and engineers responsible for making those kinds of decisions and deciding where the robot would drive. And at the end of every meeting, they would go around the room, and the chair of the meeting, which was a rotating position, it wasn't always the PI. There were a couple of different people who would chair the meetings, would go around the room and say, "Are you happy with the plan?" And everybody had to say, "Yes, I'm happy." You should try this at your next review meeting. And I say that facetiously because you shouldn't try this unless you're already in a social organization that is oriented towards producing consensus, happiness, and agreement. And that is entirely what went on behind the scenes. The whole purpose of those meetings was to try to bring everybody together and to bring everybody on side. People would look at pictures taken from the rover's point of view, marked up with images of the terrain around the robot so they could all see the same things as the same things. They would use their finely grained techniques of seeing and feeling and being like a rover to start on the same page and ultimately end on the same page. And even these kinds of visualizations that were taken at the time with the webcam in the control room at JPL, it looks like no one showed up for work that day, but it's a visual reminder. First of all, everyone is in a semicircle, everyone's in the circle together. There's no leader, we're all equal. And each of those little placards reminds you that those are the people you have to agree with at the end of the day. And as one of the meeting chairs explained to me, the whole point of this process is that people need to have a sense of ownership over the plan. They have to feel like they're part of the process. So again, the task that needs completing here is not just that we have a plan, it's that we have a plan that everybody has agreed to and feels ownership over and feels responsibility for, and that everybody is involved in that process. So the kinds of decision-making that were enforced among members of the team, the science team and the engineering team, were ones that were oriented towards this form of unilateral agreement. It was described as a kind of negotiation where it helped to sound enthusiastic. People were repeatedly sort of transformed their voices and bodies to feel sort of upbeat as part of this process and to interact together. And they kept saying, the whole point is we have to decide together what's best for the robot. This doesn't mean that they diverged into groupthink, and it doesn't mean that they ended up making bad decisions. Instead, they actually cultivated a culture of listening to each other and trying to ask each other to come up with counterfactuals, that in order to show that you were being a good member of the team, you had to think about what could be going wrong or what we might not be considering and bring that to the table as well. So the negotiation process and the thinking process, that the whole process of making this decision was one of trying to bring as many of those voices to the table as possible to make the right call. Interestingly, this wasn't just about the scientists. It was also about scientists and engineers. I want you to watch this moment when they tried to come to consensus over where the robot should go. So here's an area where Spirit was approaching a place called home plate. The scientist in charge the scientists really wanted the robot to get to this area in home plate because there were some very important rocks to go look at there. And so what he did was he put this into false color so you could see from the rover's perspective where all the hazards are, where you don't want to drive with those big boulders because you have a 5-wheeled robot that has to drive backwards at this point. And he put this little line in saying this is a minimal ridge, thinking like maybe this is a thing we could get over. He says, okay, engineers, you showed one on-ramp to home plate. It did look unapproachable or difficult. I'm trying to show these images as an alternative. I wondered if you guys had looked at as well. The engineers say, well, gosh, we looked at those southern approaches. We don't think they're viable. We don't want to get stuck somewhere we can't recover. Okay, so here we have that classic moment, right? Where the scientists want to do gymnastics with this spacecraft and the engineers are like, no way, right? So according to the engineers, the scientists are being way out there. And according to the scientists, the engineers want to fly a brick, right? You've heard these stories before. It's classic, and it's a classic divide in science and engineering on board these missions. But for this mission, this is a huge problem because they need to agree. They need to be coming constantly to agreement about what the robot is seeing and experiencing and making those decisions collaboratively together. So this is actually a very fraught moment because they have to figure out how to get these two groups to align. Now in consensus-based groups, what do you do when you have two different opinions? You come up with a third that satisfies both. And that's exactly what happened. Another scientist came in and said, okay, well, what about this area? What if we went to that area? It looks smooth, that you could approach it. It's smooth looking, et cetera. Parsed it, seemed like a rover. The team agreed this was the place to go. There's one other thing I want you to notice here, and that is the pronouns that are being used to talk about the robot and the team. And that is the pronoun we. And I'm not the first ethnographer to bring this up, but it was noted repeatedly that unless the scientists and engineers were speaking to the press about their robot, in which case they often used she, the pronoun used behind the scenes was we. We've looked at the Southern approaches. We don't think they're viable. We don't want to get stuck somewhere we can't recover. Is we the engineers? Is we the scientists? Is we everybody? Is we the robot? It's actually impossible to decide, right? That's the whole power of the pronoun we, is we are all included. And repeatedly, over and over again, people would use the pronoun we to talk about what the robot was doing in a way that brought everybody collectively along on the journey. We expect to turn around. We'll take images of that ridge. We're 4 meters away from the outcrop. They're not 4 meters away from the outcrop. They're millions of miles away from that outcrop. The rover is close to that outcrop. But that kind of language in concert with this way of seeing and embodying and visualizing and talking brings everybody together as a team on the surface of Mars to make those decisions together. So I'm going to give you one little piece of social theory here to take forward with you before I move on, and that is this concept of techno-solidarity, and that is the ways in which the people on the team feel about each other and feel about their robot. Sociologists are very interested in social solidarity and the ways in which we organize our groups and divide up decision-making or divide up tasks on our group has an effect on how we feel about each other. And one of the big findings from the study of this particular team and others is that the way we divide up the tasks and the way we make decisions together or separately also affects how we feel about each other and how we feel about the robot. And this team had the most extraordinary degrees of social solidarity between themselves and also with the robot. And that is where we see the possibilities for success. And it was that capability, that techno-solidarity happened in that space between the robot's capabilities and the team's capabilities. It happened because those capabilities of the team were not abstracted away and given to the robot, but there was space for that to flourish. There was space for the teamwork, for those relationships, and for those stories. And that's where the success came from. Okay, let me show you a couple of examples where this took place. So first, there was a moment early on, it was in 2007, when 2 faulty commands were sent up to Spirit. 2 faulty commands. The robot faulted out, and the project manager was like, that's it, everyone go home, take a long weekend, take a vacation, go for a hike. We're gonna come back and we're gonna have an all hands meeting. We're gonna talk about what's going on here. What did we lose? We used to be the fighter pilot team at the top of our game. What's gone on? And in the discussion about what the problems were and how the process was starting to falter over time, one of the engineers who'd been with the team a long time said, look, I get the feeling that new team members don't have the fear we had at the beginning of the mission that we were going to lose the robot. It's like a video game for a lot of people. It's kind of cool. It's abstracted a bit, but they're not as connected to the fact that the robot is one day away from, we're never going to hear from it again. So anything we could potentially do would end the whole game. Now, what this engineer is speaking to is that people are learning to see like a robot as if it's just a video game, right? Oh, let's joystick it over here, let's joystick it over there. But seeing like a rover isn't just having a sensibility towards visual information. It is bringing the relationship to the robot into your body. It is understanding that if you lose that robot, there's no like one up, there's no next life, right? That's it. And not only is that it for the robot, that's it from the team. We're never going to hear from it again. It would end the whole game. So what this engineer was speaking to was that sense of techno-solidarity, right? The fact that like seeing like a rover and acting like a rover is bringing us together in this relationship with each other and care for the robot. And if you're not doing it that way, you're not doing it properly, right? So that space between the human team and the robot's capabilities enabled this extraordinary relationship between the individuals on the team and the care for the robot as well, in which the whole point for newcomers was to learn not only how do you work with this robot, what are the commands, what are the tasks, what are the achievements, what are the chivos, but what's the care, what's the relationship, what are the stories, what's the feelings that you're supposed to have as well. This got pretty interesting because it led to some very interesting stories about which part of the team was responsible for the robot, where was the agency in the robot. And this is a huge issue associated with mixed agency, mixed autonomy, right? Is that the agency kind of lies between. It's not just with the robot. It emerges from the relationship between the robot and the humans, or in this case, the human team. And I first noticed this when I was speaking to a member of the Rover team who is a member of the Miami Algonquin Nation, and he was doing outreach with the Algonquin tribes, and he had to figure out how to say Rover in Algonquin, which was actually very tricky because in Algonquin, they have a concept of animacy that is a grammatical characteristic of objects, of nouns. So you had to decide whether or not the robot was animate, whether or not the rovers were animate. And as he put it, animacy is like, it's an extension of us. Things don't have it, cars don't have it, trains don't have it. It's not possessive, I have agency. It denotes what something does, not what it is. So he had to figure out how to express the animacy of the robot as this kind of mixed agency between humans and machines working together in partnership. And so we ultimately settled on that grammatical form. I'll also note that this kind of mixed agency is also what gave members of the team such rich stories about the perseverance of their robots, about their commitment, continued commitment to the mission. And I want to just show you a little, listen to a little clip of somebody again at Spirit's funeral telling the story, telling a complex story of Spirit's journey. I'm coming in sort of halfway along, in which the Spirit's perseverance alongside the team is what gives Spirit that kind of animacy and that kind of sense of agency. Here we go.
They're only designed to go more than 1 kilometer. It saw 70 something, and we out of a 90 sol mission. There's no hope we can possibly get there. And this guy actually stood up in front of the project and said, maybe if we drive far enough, long enough, maybe someday we would get close enough to those hills that maybe we'd be able to see something in there. Right? And they're too far away, right? So Spirit gives up. Obviously not, because Spirit's not that kind of rover. So she takes off and she drives, and she makes it not just to the base of those hills, but all the way up into those hills, right? She climbs to the very top of those hills, much farther than she was ever meant to go, much more than we ever thought she was capable of. And she stands on top of those hills and takes a long look at the whole world around her. And when she's good and ready, she takes off and goes down the other side and keeps on going. Now, if you can listen to that whole story, and you can look me in the eyes and tell me that she doesn't have a personality, that she's not something in and of herself, you are the robot.
All right. So here, this extraordinary story about Spirit's journey is told, without the members of the team, but as a way of expressing this kind of sense of care, responsibility, pride associated with the things that the robots and the team have achieved. And I want to give you one more quote here that brings this all together. This is another member of the team who said, look, the whole point of the hardware is it's the glue. It bonds the team together when it's being built on Earth. In that time, we can directly relate over something physical. But when the spacecraft is off the ground, the connection moves into the software realm and into our minds, arguably into their bodies as well. I'd argue the dynamics of the team took on greater meaning when Spirit and Opportunity left the planet, because once those rovers leave Earth, the team is all we've got. So here is that mixed autonomy, right? That mixed autonomy in which agency between robots and machines is slippery or is occurring, that animacy is coming because they're working together. The space between what humans and robots can and can't do is allowing for those incredibly rich stories that forge a connection between members of the team and each other and themselves and their robots, and is creating that connection between those two different planets that's enabling the kind of care that that encouraged this team to work with these robots for so long under such extraordinary conditions, many of which were quite adverse. So that's that space, right? That space enabled that techno-solidarity, that strong sense of social relations among members of the team and the robot. And that's what can flourish when we really have mixed autonomy, powerful mixed autonomy. So seeing like a rover in this way brought together, first of all, visualization techniques, software, et cetera, but also brought that into people's bodies, not as a projection of what humans can do to the robot, but what the robot can do onto the people. And in that space, in that mixed autonomous space, was where the teamwork flourished, was where the team was allowed to work as a consensus-based unit to produce that kind of extraordinary solidarity, social solidarity among team members, but also between team members and the robot. And that's what allowed them to operate these robots on Mars with such care, such attention, and such creativity for a very, very long time. And there's a couple of key points I want to end with. The first is, as many of you already know, that we can have very rich interactions with machines that don't look anything like us or act anything like us. And especially when we create software and hardware that goes into space, we are gifting it with capabilities. We are using robots that go into space that have capabilities that we do not have. I mean, first of all, that we can't breathe out there, right? But Also that we can use different, we can create cameras that have sensibilities to different wavelengths of light. We can have different temporal sensibilities. That actually forges relationships. It doesn't break it apart. So despite a push towards artificial intelligence that looks like human intelligence, in fact, that mixed autonomy space says that lots of more creative stuff can happen when humans and robots are not alike. Secondly, that humans will fill those gaps rather creatively between human and robot capabilities. Recall that Rover dance in which people brought the robot's capabilities into their own bodies and took pride in the sensibilities that they acquired. Third, that we can't automate decision-making away, because to do that is to derive the team of the lifeblood of their efforts and their science, but also really especially to lose the opportunity for creating social solidarity relations, to create relationships among members of the team, and to create relationships with a robot. Remember what happened at that intersection. Because the robot couldn't decide on its own, the team was deciding together for the robot, and those kinds of relationships proved extremely powerful and successful for this robot. So, don't take the lesson from R2-D2 and 3PO. Remember that conflict can actually be generative, and that decision-making groups do have ways of coming up with the right kinds of decisions, and giving them that space to do that actually will allow the team to flourish. And ultimately, that we need to create the kinds of flight software conditions that make space for teamwork, that make space for relationship, and that make space for these stories. And that it's in that mixed autonomy space, it's in that mixed autonomy world that we can find these creative alignments and misalignments between humans and machines that enable us to do more than either of us could do alone. And so that's where I hope that social science can also provide you with some understanding or some better insights into how humans work in groups and how decision-making works in teams, but also how to bring that together in synergy in human-robot relationships and human-robot partnerships as we explore space. So I'd like to thank you very much for your attention. I welcome questions in the remaining few minutes. If you're interested in knowing more, the book that captures some of this is called Seeing Like a Rover. I have a new book that's also been released called Shaping Science, which goes into some more detail about the technomorphism and techno-solidarity, but also does more comparative work with other teams. But I'm really excited about the work you're doing, and I'm really looking forward to the conversation. Thank you so much.
Thank you so much, Janet. That was amazing. We do have some time for some questions, and so
Great.
I'll try to go through some of the ones that we have.
Thank you.
So
you'll moderate, right?
Yep.
Good.
I'll read them off from the Q&A.
Okay.
So the first question from Alan Mick is a Rover question. Do people identify with their cars somewhat in the same way that they do with the Rover? Sometimes when close maneuvering in a parking lot, for example, there is a sense of the car's boundaries.
Yeah, it's a good question. Jack Katz, who's a sociologist at UCLA, has this great paper about driving in traffic in Los Angeles, which is essentially about that, right? About how your car becomes the extension of self, but also how everyone else's cars are the extension of themselves, and how you're likely to, get really angry at those cars as they're moving in and out in front of you, and that you kind of develop a sensibility to where the boundaries of your car are. So this is something that we already know from sociology. What I think is super interesting in this case is that those individual relations are actually group relations with respect to the robot. So with respect to the rovers, it's not one person, one robot, or one person, one car. And this is where I often describe being on a robotic spacecraft team is like being on a bus with like 350 or 500 people, and everyone wants the steering wheel. So it's a different kind of techno-solidarity relation, because you're working with so many different people and you have to kind of bring them all along for the ride. And whether or not you do effectively or don't is going to be it's going to make or break the mission, right? So part of what has to happen is that everyone develops that sensibility together, because it's through that shared sensibility that they will have some premises to work from as they start making those decisions, especially because they come from so many different backgrounds and disciplines and experiences. It's that shared sensibility to the robot's capabilities in their body that lets them work together. Great question.
Next question from Alexandra Holloway at JPL,
Hi.
who I believe is a member of the Curiosity team.
Hello.
How can we introduce new technologies such as auto-nav and auto-targeting and help them get adopted by a mixed young and old team?
Oh, it's super tricky. Yeah, good question. There's a lot to say here, actually. So when systems get super automated, people tend to kind of create stories about what that system is and how it works because they don't really know. So we see this in studies of like Uber drivers, for instance. So my colleagues who study algorithms will talk about, like, there's what the algorithm actually does. There's like the actual code, but then there's the stories people tell about the algorithms, the folk tales about the algorithms that make sense of why it's telling you to go over here or go over there, right? And make sense of why the algorithm is making like bad decisions when it makes bad decisions as well. And so I think paying attention, so when you move to much more automated processes, auto nav, auto targeting, et cetera, what you're going to find is, because they get so much more complicated with the automation, and people that work with them they're not going to look at the code base. They're not really going to get the code base. They're going to create folk fictions or narratives about why the robot is doing what it's doing at a time. And what I would say is it's really important to track those and pay attention to those. Not because you want to make it line up perfectly with the code, but because it'll give you a sense of how satisfied or dissatisfied they are, and how well or poorly that decision-making is fitting in with their decision-making. So when people are like, well, that's the auto nav, working up again, or that's it's having its problems, or that's when they're ascribing a kind of agency to the navigation systems that's not positive, right? Now, I saw on this team some really interesting moments where the robot kind of like screwed up, but nobody was mad at the robot for screwing up. It was an opportunity. So the Spirit broke, and its wheel wasn't working. They had to drag it. And then that's how they turfed up the light soiled terrain that showed that it had been a hot spring there. They stopped calling it our bum wheel and they started calling it the trenching tool. In moments when the auto nav screwed up, like there was one maneuver they were trying to do and crunch a rock and it screwed up and they got the wrong rock. They called that rock innocent bystander, and that rock ended up being like the way that they solved all the problems. So they were constantly it wasn't just that they were like making lemonades out of lemons. It was more that they could kind of encapsulate that automated system and still see that it was doing good things for them. And so I would pay attention to the narratives people have about that system and whether that's positive or negative. Because once you start getting to the point where people are telling stories about it that are like, it's screwing it up and it's really messing it up for me and I want to throw this thing out the window, that's affecting your solidarity relations. And that might mean you need to take your foot off the gas when it comes to automation. It's not just a question of getting these PhD holding, quite technically expert scientists to understand the technical expertise of your algorithm. It's also maybe taking a step back and saying, maybe this isn't what they want. And what if we change the mixture of the autonomy here? But it's a complicated question, and I'd love to keep talking about it because I get excited about these things.
Okay.
Yeah.
Next question. At the beginning of this workshop, it has been said that software animates these vehicles, and software designers are in the end the pilots of these vehicles. Do you see a distinction between relationships between humans and software and an overall relationship of humans and the overall vehicle?
So I would say that I'm super sorry. I don't think the software is the pilots, but the software that I've seen is the conduit. It's the control panel. It's the medium. It's the infrastructure through which people can do anything at all. So it does provide the capabilities and the restrictions inherently to the software, right? But what's interesting about the people working with the software is they work incredibly creatively. And if you give them the tools to do so, they can be extremely creative. So the things that this team did with this robot were not ever intended. Not only did they get it to like climb hills and mountains it wasn't supposed to climb technically, but also in terms of like software capabilities, they got it to do things that were very, very creative. And that was because they were able to work creatively with the software and the hardware, because they had a way to bring that all into their bodies. But I mean, to a certain extent, like the seeing like a rover is not just seeing technically like the rover, it's bringing the software capabilities into their bodies as well. Remember that thing with like the PanCam squares, or like the ways of seeing that were inherent to the software, like the lily pad maps, right? But those were all things that became part of the perceptual apparatus. So I would say it's not so much that the software is the pilots, but you're giving them the tool, you're giving them the control panel that they get to then work with, right? And that control panel looks a lot like a 747, right? There's a lot of different things you could do. But what you actually want them to be able to do is to be creative in their composition of what the robot can and can't do, because then it's going to outstrip everybody's expectations. But I guess that's where the mixed autonomy is. It's very hard to say like one thing as a pilot, because it's all working together. And I actually think that's the goal.
Okay. And I think that leads in well to the next question from Sarah, which is, I noticed that you use the term mixed autonomy as opposed to human machine teaming, which I usually hear. I'm curious, is the goal of this to normalize the idea that the rover is a member of the team? And are there other instances of intentional language use shifts that you think would benefit mission teams?
Interesting. So the mixed autonomy stuff comes from HR, like human robot interactions. It's sort of a way that we now have started to talk about what humans and machines do together, largely because it's a pushback against the notion that the machine should be entirely autonomous. And I'm sort of part of a group of researchers who are thinking creatively about what it is that humans bring to the table where the robots don't. And that mixed autonomy is a way of thinking about autonomous systems that not only have humans in the loop, but like the humans aren't there to be automated away from the loop. They're actually contributing something important to the loop. And the thing I think is interesting there is that the humans are working as a group in the loop, right? It's not just like I'm a single person and my psychology has changed because I'm interacting with a robot. It's that my sociality is interacting with the robot. And that I think is what's really important. So that's why I use mixed autonomy. Human machine teaming is, I think, another powerful way to get at a similar kind of premise where the robot is itself part of the team. But then I think it's still a little bit more separated. Like the team is doing some deciding, we code some stuff, we send it to the robot does the thing, the robot reports back, the team does some stuff. So we're kind of like, we're working together as a team, but we're not like fully synergized. And what I thought was super fascinating about this team was the mixed autonomy was super present in the way that they, even in the stories they told, right? That seeing like a rover was there to make you feel committed to, like you don't want to lose it. The stories, the rich stories about like spirit not giving up. And if you can't tell that story without giving the robot some agency, you're the robot, right? That the feeling is a part of it. It's not just a like, okay, I've done my part and I'm handing it off. So all of those things are coming together in a mixed autonomous system. And that what I think is so important about that is that you could look at that from an engineering perspective, and people do. I've written about this in other fields, right? Self-driving cars. The premise of Uber initially was to build self-driving cars, but we're going to get there by putting people in charge of the car. We're going to algorithmize that. And then eventually those people will go away and we can just be entirely autonomous. We've since realized that that didn't work as well as we thought. But the premise there was still this notion that there could be this kind of seamless replacement of the human with the machine. And I think increasingly, fortunately, we're now thinking about artificial intelligence as synergistic and partnering. And that the goal of artificial intelligence is not to replace or to perfectly reproduce human capabilities, but to augment, synergize, challenge, interact with human capabilities. And that's where I think the mixed agencies, like the mixed autonomy stuff is so fascinating, because you can't just be like, it's one thing that did it. It's the whole thing. It's the whole shebang that's doing it together. So that's where I would say like my preference would be this kind of mixed autonomy, but human machine teaming, I think gets there. It's just like you choose any kind of arrangement for the team. Okay. Go ahead.
A couple minutes left for the next one. So we got next question from Jonathan Zimmerman. The room for the human-robot interactions were made possible by the modern advancement of rover capabilities and autonomy at the time of Spirit and Opportunity. While it may be important to retain decision-making, does increasing autonomy in artificial intelligence allow us the opportunity to apply our decision-making to different and more interesting problems?
Yes, if it's done correctly. Yes, if it's done towards the goal of applying decision-making to more interesting problems. No, if it takes away the opportunity to confront complex and interesting problems, then I think we're barking up the wrong tree. I was a little worried when I heard that there's some like onboard capabilities. I think they built into Percy, right, where it can decide which things might be scientifically interesting for the team. Like that's where the action is for the scientists, is looking at stuff and being like, what is that? And let's go look at it, right? So the serendipitousness that humans are so good at, right, is figuring out like, is that a pattern, right? That's really interesting. Let's check it out. Now, it doesn't mean that machines can't participate in that. It just means that machines should respect that humans are really good at that, and machines might be able to say, here's a prompt. Are these things a pattern? Are those things a pattern? I'm noticing a thing. Is this a thing you think is important? Those are the places where I think you can get humans and machines in some really interesting conversations. If we just delegate all of that to the machinery, there's nothing for the humans to do. They get bored. The machine becomes replaceable because they don't build a relationship with it, and they don't necessarily build a relationship with each other. So those may be things we want, right? In the future, we might want everyone having their own drone on Mars, and they're all kind of like, you know, throwaway drones and whatever. We got like 80 million of them up there, and you can dial in or dial out whenever you want, right? Like if that's the goal, then go for it. Please autonomize the heck out of that stuff. But if we're looking at these really rich scientific discovery-based, like exploration-based missions, Dragonfly is another great example of this coming up on the horizon, right? We're going to look at stuff we've never looked at before, and it's going to be contingent, right? Contingent on where we are, how we wake up, and what it's like on the planet that day. That I think making space for that interaction is where the discovery is going to be. Don't make the discovery just in the robot's brain, please.
Okay. Yep. And last question, real quick from Sarah. I find this domain so fascinating. Beyond your books, which I will absolutely be reading, are there particular professional societies, communities, podcasts, etc., that you would recommend to learn more about the intersections of sociology and space mission teams?
Oh gosh, great question. So there's places to learn more about the sociology of human machine interactions, for instance. So the human robot interaction, ACM conferences, right? For instance, HRI is one of them. HCI, human computer interaction, is another one. Another one I go to is computer supported cooperative work, which is a very long way of saying these were the people that first started studying like remote and digitized workplaces. Those are some really great places where people are talking about humans and machines and teamwork. A really great colleague named Malta Young working at Cornell also on similar kinds of questions. In terms of the interaction with space, there's a more multidisciplinary group of people that are looking at cultural aspects of space exploration. So anthropologists, sociologists, psychologists, etc. There was a terrific conference online in the spring of 2020 that was called Space Science in Context. And a lot of these conversations are happening around pressing questions of diversification, for instance, in science and engineering teams as well. And so like those would be really good places to look for these continuing conversations. And there's a group called, I think, SOCIA, which is also like the social sciences of space, astrobiology and exploration. So there's a whole bunch of us out there. I'm not the only one. I'm happy to give you other lists of people to look up or read. Valerie Olson, Lisa Masseri, also two of my favorites, but there are many others. And I hope we get to continue these kinds of conversations because I think that's where the fun really is going to be.
All right, that's all the questions we have time for today. Dr. Vertesi, thank you so much for your time this afternoon. I know I really enjoyed it.
Thank you so much. Have a great rest of your day.
Thank you.